Welcome friends, this is Parthish. Here I am with an introductory course on control systems, especially for the undergraduate learners of engineering and diploma studies. As such, control systems is a huge subject, and in undergraduate courses we will learn a specific part of the complete subject. So we will go through the basics of the subject in this course, and as because there will be a series of episodes of this course on YouTube, you need to subscribe this course to stay connected and for updates. By the end of this session, if you like it, you can press the like button. So I am teaching this course for quite a good time from now, and as per my experience, the subject control system will require you to go through the fundamental definitions first, then understand how different mathematical tools are used to realize certain applications of the subject. Because control system is a subject which is equally important not only for the electrical and electronic engineering candidates but also for other fields of engineering, because this subject includes the modeling of different things which we see around us. So it can be from civil engineering, mechanical engineering, aerospace engineering, or even computer science and engineering. So anyone in the engineering field who is involved in designing of things which will define later as systems can audit this course. So you can even email to me in case you have certain queries. So this is my email ID, parthish.k@gmail.com. Otherwise, if you go through my lecture series gradually, as and when it comes, you go through it and you can ask your queries, or you can go through my lecture series again and again to have better understanding of what is exactly taught in the subject. So this is the ease of the YouTube, that we can go through the same lecture repeatedly if we miss certain important points. So here again I am emphasizing that control systems is a huge complicated subject, and we will learn some basic concepts of the subject finally to realize certain applications. So in fact, what are these applications? These are all the applications which are meant for a betterment or ease of human life. For example, suppose I want to go from one point to another point. I would like to find out a conveyance of vehicle or medium through which I can go in the most convenient way, in the most safest way, or even by the cheapest expenditure of fuel or money. So there are certain functions which we use in control system so that we can define different things, different materials, different machines in terms of certain functions, and these functions will have mathematical models, and eventually by solving those mathematical functions or models we can find out the best results for our problems. So we will start from the simplest examples around us, then we will come to the mathematical nitty-gritty of the subject. As such, control engineers try to find out the things around us which are mostly practiced by the nature and imitate it for the betterment of the human life. You can see the example of the game of trapeze, where a very skillful play of mind is used to play the game. So this is all about human mind, which is trained or skilled in a proper way to play the game of trapeze. So now in control systems we are trying out to find out different dimensions of human mind so that we can make similar things or robots which can support human life in a better way. You can take examples from nature. the solar system, which is a very small part of the Milky Way. But this Milky Way has been developed in a very systematic way. The nature has played the best control systems to define the universe, and our solar system is the tiniest part of this example of a perfect control system of nature. You can see the birds flying in a special pattern while they migrate from one place to another. This pattern is called the formation flight. During the winter season, birds migrate from Siberian region to the relatively hotter places, even like India and Nepal. So this flight of several thousand kilometers is covered through a different technique in which they interchange the mutual storage of energies, and without any intermediate haltage they complete the flights in single go. So how this happens? This is the beautiful example of control system in nature. Another example, if you take, is the rainfall. Every year during the month of summer and late summer, when it is the rainy season during July, August and September, we have rainfall in smaller and larger quantities in different parts of the country. You can see the rainfall of different places are more or less statistical. I have taken the example of a village in Meghalaya which is named as Sohra village, where the rainfall is maximum in the month of July, somewhere more than 3000 millimeters. Can anybody in this world say what are the various causes due to which this rainfall happens? This is surprisingly beautiful example of nature where we don't know how exactly the rainfall happens, but during these seasons, due to different reasons, we assume that now or then the rain will fall. So there are examples in control systems where we can distinguish between two different kind of situations where a rainfall is happening but the exact reason is not known. We call these systems as, or situations as, stochastic systems or situations. In another example, suppose you have a small motor to which you are supplying a voltage and the rotor rotates, then that is an example of very simple deterministic situation where you have the supply voltage and the rotor is rotating. Another example of nature, the picturesque view is from the Satpura Tiger Reserve in MP. Here you can watch that the mountains are there, greeneries are there, and it seems to be very abrupt and random. But in fact, this is a very systematic creation of nature where everything is independent in its own way. A forest develops through the nature and nature maintains the forest. This is unlike the urban places where human life is affected even if a single hour of power cut is there. So there are such great examples of control systems in nature where the very cause of the system or situation or the result is not known. So the control engineers in due course of the development came to the place where they started imitating the humans itself. And the example I had taken in the beginning of the game of trapeze, where human mind are being tried to be copied and be imitated. So this robot Sophia is a very well known development of humans in Netherlands. So this robot is a result of science, technology and artistry combined together. So main purpose of developing this robot is to give services to humans and also for the entertainment applications. So here comes the latest phase of advancement of control systems, where we are speaking about the artificial intelligence. Although this topic is beyond our syllabus in this series, but this is the latest development in control systems. Now come back to the situation of the formation flight of birds, which has been imitated while we are observing that several aeroplanes are flying together in the same fashion. This is again called the formation flight of jets. Another example of control system, which is a ship, the latest battery operated ship, which can be seen in the Arctic Ocean. Such examples of control systems have resulted in long run because of the gradual development of the subject. So beyond this, we start with the simplest example of control system, where a ceiling fan is being controlled by a remote control, where its speed, its lighting can be controlled remotely as well as manually. Air conditioners are other examples of sophistication of control system in application. So we have several examples of control systems in real life. In fact, all the sophistications of developments of machinery in real life include the mathematics of control systems and its applications. So the subject along with this tool is that mean by which any quantity of interest in a machine, mechanism or other equipment is maintained or manipulated according to human desire. Because eventually we want to find out that the human interest is satisfied. If the human desire is not satisfied, then we don't appreciate that design. So the final story of all this hard work is that the human desire or human interest or human service is satisfied. So the example can be taken of the temperature of a confined place or a closed place which is controlled using an air conditioner. So there are different ways how we can control the temperature of a room or a confined place. So throughout this series of episodes, we will go through different topics of the subject. But in the beginning itself, I would like to declare that this introductory course, as it is given by different universities in undergraduate programs, is basically the linear systems theory. Control systems as a whole to be taught in the undergraduate programs is the linear system theory, where we will use the linear mathematical terms, definitions and calculations. So basically the linear system theory will use the concepts of linearity of systems. Now the system with some forcing function and a desired change in its behavior will be addressed in this course, because when we are speaking about the linear system, we will give you certain inputs, certain forcing functions, certain fuels, which will determine how a result, a output, a movement, a motion or a final temperature can be controlled. So you have a forcing function which is the input to the system and a result which is the output from the system. So these are two variables which we will work out throughout the course, and our intention will be to design a good thing or mathematical model in between this forcing function and the desired output or desired change. Again, the modeling of systems with linear systems theory and suitable controlling techniques for the given systems will be studied in this course, as I have already mentioned. The responses of control systems are basically observed by human eyes in time domain, that is along the time axis. Whenever you are forcing a function, suppose you are pushing a cart or car, it is having some movement along a line or along a curve. So this is your observation in time domain. So we'll study the time domain responses of systems, but at the same time, whenever there is a movement in a system or a system is working, there are different frequency zones in which the system will stay or system will pass by. So we'll study the movement of the system along frequency axis also. So stability of the system and the control will be dealt using basic tools, because whenever we are speaking about a system or a machine, for its satisfactory working, it should work stably throughout its period of working. So throughout this course we will study different mathematical tools, starting with the basic terminologies and definitions like system, control system, linear system, and so on. We will more emphasize on how certain mathematical applications will come up with field applications, and that will be illustrated in this session. As we have seen the different examples from nature and sophistication in the applications. So eventually I recall that you can send your queries to my email ID. Assignments may be provided to interested students or those who are interested in putting some queries. Queries related to different projects and control systems can be sent to my email ID, which is already mentioned to you. So if you like this session, you can press the like button, as well as to go through the further episodes of control system, you can subscribe this course. Thank you for your listening.